Hi, this is Shrikar. I'm from Team22. So we have developed a language called feasible language with the help of Prolog. I'm going to share the PPT of our program. Yeah, this is our feasible language. So we have developed the feasible language with the help of the Prolog compiler. So the basic structure of the feasible language follows the structure of the Java. It follows the basic syntax of Java, and it supports all the operations of arithmetic, assignment, comparison, and logical operations. So we do have different types of data types like primitive reference, and in primitive types we have integer, character, string, and boolean. And in reference type we have integer, character, and boolean. And our feasible language supports all kinds of control blocks like for each, if else, while, and for loop, and it supports all kinds of print statements. So those print statements are similar to the print statements in Java. It follows the same syntax as if Java. So the for each loop here, it behaves same as a for in range loop in Python. So it is similar to for in range loop in Python. So yeah, this is a grammar of our feasible language. So it opens with a f open and closes with f close token. So we do have declarations and commands between the program, and in declarations we can either declare a program or just we can declare a variable or just initiate the variable. And we do have different types of commands, and each command is as follows. Like it can provide an command to perform if else statement, or a for each statement, or a for loop, or a while loop. So it can either call a command to print the output for the user. And we do have different types of boolean expressions like equal to, less than, greater, and not equal to. And we do support different kinds of arithmetic operations like addition, subtraction, multiplication, division. And we do have the support for logical operations like and or. So at the same time we support unary operations like post increment, post decrement, pre increment, and pre decrement. And we do support ternary operators. So yeah, coming to the execution of our implementation of our programming language, we have developed our programming language with the help of the Prolog compiler. So in order to design the parse tree and the semantics for programming, we have used Prolog libraries like tokenize to generate the tokens for our language. So with the help of tokenize library, which is a inbuilt library in Prolog, we have used that library and we have developed the tokens. So we have separated the words, punctuations, control, spaces, numbers, and strings separately as the tokens for our language. And then we pass those tokens to the parse tree, and we generated different kinds of declarations, commands, and boolean expressions uh, for the parse tree. And yeah. Yeah, hi. So this is the execution of our program. So we do have the tokenize Prolog file where we perform the tokenization. So, and this is a parser Prolog file, and we do perform the parsing here. And this is an evaluation part. So we do have the evaluation part for our program, and I'm going to just run this program. So, and one more thing. So we are running our program in a sample code where we declare different types of data types, and at the same time we perform logical operations and if else statements. So I'm going to just run our program. So this is the in run command for our program. So I'm just calling the logical operations code. So yeah, so we are just generating the tokens here, as you can see. and the intermediate code and the output of our program. And these are the final environment of our program. Thank you.
Hello, my name is Himashri Gudavalli and I'm from Team 22 and our project is feasible. So now I'm going to explain the design or flow of our language. So this is the input source code. We are using Prolog to do lexical analysis. It helps us to build our lexer. So when the user provides the input source code to the lexer is going to open the file and then stream tokens from the source code. The output of the lexer is given to the token stream, which generates a list of tokens from the given source code. We are using Prolog to generate a parser tree, a parse tree. This is the parser. So tokens are given as input to the parser, and then output of the parser is a parse tree. So we are applying semantics to the parse tree which we have constructed. The intermediate code will then be executed and then the output will be displayed.
I'm Shrivali from Team 22. The language which we have designed is feasible. Today I'll be explaining about the lexer parser and interpreter which we have designed for our language. Firstly, the lexer. So we used Prolog to do the lexical analysis, and along with this we used a tokenized library present in the SWI Prolog. So when we input a source file, the lexer will take it and outputs a stream of tokens. Our lexer which we have designed has 6 different options, or it accepts 6 different types of tokens. So after generating this stream of tokens, along with the context-free grammar, we give them as input to the parser which we are going to build. So the parser for our language is also written in Prolog, and it represents the syntactic structure of our language. The output of this parser is a parse tree and also an intermediate code. So for getting the final output or expected output, so we have to input this parse tree to an interpreter. So coming to that part, the parse tree is then interpreted to give the expected output. So semantics are assigned to the parse tree that we have constructed. So after the semantics are assigned, the intermediate code will be executed and an output will be displayed as expected. So this is the working of lexer parser and interpreter which we have designed to our language. Thank you.
Hi, this is Bhavna Priya. I am from Team 22. And continuing on from what my teammate talked about, I'm going to talk about the semantics. I'm firstly going to give you a small, short brief about what semantics are, and then I'll talk about how we've implemented the semantics in our programming language called Feasible. So let's begin. All right. So how would we define semantics of a program? Is that first, to understand semantics, we have to understand some regular syntax of a programming language. So when we talk about the syntax of a programming language, we're basically talking about the grammar of the programming language. So when we define, for example, in Java, we end each line with a semicolon, right? So that is part of the syntax for each programming language. And that is basically how we define some of the features and some of the grammar of each of the programming languages. But when it comes to the semantics, a semantics is defined by the meaning of the command or of each declaration that we make in the programming language. It has nothing to do with how we write the program. It just checks if the command that is written makes sense. And this is, semantics is a very hard part to explain, essentially because how do you define if a sentence or a command makes sense, right? it can be defined on the basis of the grammar of the programming language that we're creating, right? And this can be done because each grammar of each programming language has some constraints that allow certain things to be executed. Some things will throw some exceptions, some things will throw some errors. This is because the language is defined in such a way that it only performs those specific actions, right? So when we talk about the semantics of the program that we've been able to implement, we were basically using some evaluation predicates to evaluate if the semantics of our language is accurate. So we've made use of some evaluation predicates for each of the different parts of the grammar that we've defined. So for the grammar, like you've seen earlier, we have a program block, we have some declarations. So in the declarations, we have something called the declaration dash, and then the declarations part, sort of like a declaration list and then a declaration. Then we have the commands evaluator. Then we have an evaluator for the Boolean expressions. Then we have an evaluator for the unary operator and the ternary operator. We have an evaluation expression for the logical operators, and then we have one evaluator for the and or evaluation expressions. Next, we have the expression for the arithmetic expressions, and evaluator for assigning the value, and for each block, and for the for block. And that's what we've been able to implement. So thank you.
Hello everyone, this is Kritika from Team 22. Now I take you through the parse tree generation phase of our project. Let me share my screen. So this is the sample parse tree generated for this sample input source code. So we have program block as a main node and the program variables and assign variables. So this is the variable declaration part, and this is the operations performed on the variables. So once the parser takes the input stream of tokens from the lexer, it will generate the parse tree using the prolog and DCG. So here it creates a parse tree in such a format like the abstract syntax tree. We handle the left recursion in the parser, and also we made sure we support association by ordering the mathematical operations. Parse tree is very similar to our grammar only, like we have statements for program block, commands, data type, variable declarations, loops, print statements, and all. So in its raw state, we provide this parse tree to the semantics file, which is our interpreter that has the eval statements to run. And that's how we eventually arrive at the final output with the interpreter. Thank you.